And welcome back, everybody. Hey, we're looking at the assignment for April 30th. Let me go to the file, and here we are. Chapter 12, Lesson 8, we're talking slope. We're going to be talking about this for more than a day. That's why you see 12.8a. But first, let's pause. I want you to do your Day 5 review and come on back when you're ready. So let's go through this fairly quickly. We're going to start off with y is greater than 6. That means all the numbers to the right will work. 7, 8, 8.5, 8 3/4, 8.994, 8.994 million. Please notice 6 greater than 6, that is a false statement, so leave that an empty and open circle. Do not color it in. Meanwhile, 25 divided by 5 is 5. 45 divided by 5 is 9, so x is 9. Yes, you can use cross products if you wish. The opposite of all those positives would be going down repeatedly, and therefore that should be a negative 49. And let's just slide right below it. Negative 4 goes down, positive 9 goes up. We are definitely above water. Take away those zero pairs and you'll figure out that 5 is left over. Does this represent a proportional relationship? Let's go ahead and set up the ratios: 10 to 0, 15 to 2, 20 to 4, and 25 to 6. Now, quickly notice, first of all, can't divide by 0. Secondly, 15 divided by 2 is 7.5. 20 divided by 4 is 5. 25 divided by 6 is 4 and a 6. Yeah, those ratios are not proportional. Meanwhile, we could have also noticed it because it does not start at the origin, right? So therefore, that's not proportional. Meanwhile, 10 times 10 times 10 is 1,000. And of course, inches times inches times inches, we're talking about how many cubic inches would fit inside that space. Pause if you need, rewind, go back. Otherwise, we continue on. Get rid of the 10. That leaves you with 7x's equal 14. Split it up into parts of 7 or 7 parts, and you could say that x is 2. 8.5%. $30 sweater. You're looking for the tax. So 100 times some mystery number t is equal to 30 times 8.5, which I hope is 255, but I just did that mentally. Tell me if I made a mistake on Monday, please. Meanwhile, divide by 100, excuse me, and we'd get $2.55, which seems a reasonable answer for an 8% tax on a $30 sweater. 10% would be $3, right? So this should be a little below 3. Marching onward, circumference is 2 pi times radius, and in this case, let's see here, the donut diameter is 4.5. Now, if the diameter is 4.5, then each radius would be 2 and 2/2500. Sorry, that's so messy. Of course, if you multiply 2 by 2/2500, you get right back to 4.5 times pi inches. That is an exact answer. If you go ahead and multiply that by pi, you will get an approximate answer. Let's see, 4 times 3 is 12. It's going to be 13, 14, somewhere in that realm. This is an exact answer. This would be an approximate answer, but pretty stinking close. Hey, how about number 10 in the measure of angle A? Angle A and angle 110, those are vertical angles, and therefore they are congruent. So angle A is also 110 degrees. Factoring out 8x's plus 2, means we can split these both up into 2 groups. 2 sets of 4x's is 8x's, and 2 sets of 1 is 2. On the spinner, how many times would you expect to land on a red if you spun it 100 times? Well, first of all, we see that red is a fourth of that spinner. So 25% of 100, 1/4 of 100, well, you guessed it. Now listen, this is not going to be an exact, right? Probability does not mean certainty. So you spin that, it's going to be close to 25. It might not be exact, but that's okay. That's day 5, ladies and gents. So onward we go. Our goal today is two-pronged. Firstly, we want to find the slope when we're given 2 points. Secondly, we want to graph a line when we're given its slope. Now, we have graphed stuff before, but we've used a t-chart before. We're not going to do that anymore. We're going to use the slope. And this should lead us to systems of equations, to graphing equations without using a t-chart. So I'm going to plant that little seed in mind for you. Is there any way to graph that without a t-chart? Follow along as we go. Slope of a line, ladies and gents, is just that. They use the word slope on a hill for that reason. It is kind of the steepness, if you will, of a hill. Now, we often will refer to it as the rise and the run. Vertical change, how much it goes up or down, versus the horizontal change, how much it goes left versus right. Be very careful not to flip those around and do the run versus the rise. That is not what slope means. All right, types of slope. If the line is increasing, so we're talking going up and to the right, that is a positive slope, ladies and gents. However, if the line is decreasing, going down and to the right, that is a negative slope. Now, just want to remind you, I think we've talked about this before, you can go up and right because a positive divided by positive is a positive. But guess what? You could also go down and left. And if I'm thinking about this, a negative divided by a negative is still a positive slope. Now, in this case, going down and to the right, the opposite of a positive, is a negative. But we could also go up and left, a rise and a negative run. Guess what? The opposite of a positive is still a negative. So I want you to think about that in terms of slope. That's why generally we want to see it's rising to the right or falling to the right. Meanwhile, what if you have a rise of 0? Maybe it's 0 divided by 3. Maybe it's 0 divided by 2. Maybe it's 0 divided by 5. But you know what? 0 divided by anything is 0. And I want you to think about that. Yes, that is possible. So think about skiing. Can you ski along this slope, this hill? Yeah, it's not very fun. It's a flat surface, but at least you can do it. Can you ski along this slope? No. If it's vertical, ladies and gents, there is no definition. It's undefined. I want you to think about that. If you think about a rise of 2 and a run of 0, what's 2 split into? I beg your pardon? The truth is, you cannot split any number into groups of 0 and still have that number. You can't take $2 and split it into groups of 0 and still have $2. I can take $0 and give it to 2 of my daughters because guess what? They're both getting 0, right? That is possible. Not very fun, but possible. This is impossible. Cannot ski along that slope. You cannot divide by 0. Slope is a ratio of the change in the vertical, we've talked about that, versus the horizontal distance. And yes, we should now be able to come up with some numbers. So because this rises up 1 and it runs to the right 2, it's going to be a puff positive slope. Sorry, that didn't work out so well. So in this case, it will have a slope of 1 to 2, 1 to 2, 1 to 2, constant rate of change. In this case, I'm not a big fan of these arrows. And if you ask me, they should always do the rise first. And so this appears to go up 4, and it goes to the right 1. 4 to 1. You may leave it as 4 to 1. You can divide it into a integer. I would take that. Now, what if you do the other way? What if you go down 4 and then to the left 1? Oh, look at that. What's the opposite of a negative? So because the opposite of a negative is a positive, you'll still have a slope of positive 4 to 1. I don't care which direction you go, sooner or later you're going to realize that it is a positive. How about this one? I'm seeing a rise, or maybe I should say a fall, of -4, and a run of 1, 2, 3, 4, 5 to the right. Now, 4 to 5 neither divides nor reduces, but the opposite of a positive is a negative. On the other hand, what if I start down here and I go up first? Up 4, to the left 5, Well, shucks, Mr. Callan, that's the same thing. What if I try it and go way down? Down 8, to the right 10, down 8, to the right. Well, that reduces by 2, and you get the same answer. So it doesn't matter which direction you go. It doesn't matter which points you use. It will always reduce to the same slope. That's why we call it a constant rate of change. It is going to be the same or a constant slope. All right, now, if you'd like at this point, you can go to your assignment. I have put some notes right here. And these problems are going to be just like our homework. So draw a line that passes through each pair of points, then find the slope in simplest form. And I might put an extra star at the y-intercept as well. All right, 3, 4. Now be careful. While slope is rise first, for an ordered pair, it's always the x value first. So positive 3 goes to the right. Let me start at the origin here. Positive 3 goes to the right, 1, 2, 3. Positive 4 goes up, 1, 2, 3, 4. And there is our first ordered pair. Now let's go ahead with -1, negative. Well, that's not so bad. -1 goes to the left, -1 goes down. And so at this point, you can take out your straight edge, take out your ruler. If you're doing this online, there's a nice little line function online where you can, let's see here. Let me try, that didn't work. Try that again. That didn't work. Try that again. There it goes. And let me go ahead and extend. Always make sure your line extends all the way through. And of course, just because our coordinate plane stops doesn't mean this line stops. So let's draw the arrowheads on both sides. Now we will find the slope, ladies and gents. So I'm going to first calculate the rise. It goes up 1 and 2, 3, 4, 5, up. And let me calculate the run. 1, 2, 3, 4 to the right. Does 5 to 4 divide or reduce? It does not reduce. And I don't feel that it would be a wise idea to change this, because what is a slope? A slope is a rise versus a run. That's a relationship of two things. But if you write 1 and 1 over 4, what's the rise and what's the run and what's that third number? It's not that that is a bad way of representing it. It's just not the best way. Best way of representing it, positive 5 to 4. Little bonus here, let's put in the y-intercept. Sure looks like the origin to me. And we'll keep talking about that y-intercept, because sooner or later, you guys should be able to use that slope and put that starting value in place. And you're going to be able to come up with an equation without even looking at a t-chart. But that's what's heading at you eventually. Let's go. 1 to the right, positive 1, 2 up, positive 2. How about 4, 4? Positive 4 to the right, positive 4 up. Let's go ahead and draw this line, shall we? Best that I can all the way through the graph with the arrowheads. Now let's calculate the slope, shall we? Calculating a rise of up 2 and a run of to the right 2. Now positive 2 to 2 does divide or reduce quite nicely. You may write 1 over 1, or you can just write 1. I'm going to guess that most of you will write 1 whole. But I have no problem at all with writing 1 over 1, because after all, what is a slope? It's a comparison of a rise and a run. Y-intercept appears to hit right smack there, and it looks like 0, 1. Next, -3, +5 will be in the second quadrant, because -3 will go to the left and +5 will go up. +2, -1, 2 to the right and 1 down. Drawing our line through here, go ahead and take out your straight edge, ruler, whatever you need. And let's try to get that a little further through. Now let's go ahead and calculate our slope, shall we? So let's find a rise, or maybe I should say a fall. 1, 2, 3, 4, 5 goes down. Nope, wake up, Mr. Callan. That goes more than 5. 1, 2, 3, 4, 5, and 6 down. 1, 2, 3, 4, 5 to the right. -6 over +5. Does that divide or reduce? No, sir, no, ma'am. What's the opposite of a positive? That is a nice negative slope. And we'll go ahead and take the star. Boom! Where does it intercept that y-axis? Right at the point 0, 2. Now, ladies and gents, those were problems where you were asked to graph 2 points and find the slope. Now we are asked to draw a line with the slope and the given point. So quite frankly, I don't know how to go up and to the right until I first graph the slope. Step number 1, or excuse me, the point. So step number 1, put that point in. Step number 2, let's use the slope. I'm going to put a little disappearing ink in here, and then I'll plot my next point. This says a rise of 3, so I'm going to count up 1, up 2, up 3. It is positive. A run of 4 goes to the right. 1, 2, 3, and 4. And so our new point will be right here. But you know what? That's not good enough to me. So let's do it again. Let's take another rise of +3. 1, 2, 3. And another run of +4. 1, 2, 3, and 4. And there's another point in this relationship. Oh, you know what? I want to keep going. Okay, wait a second. Now we run into a problem. If I do a rise of 3 and a run of 4, it goes off the graph. But wait a second. What if we go in the exact opposite direction? After all, the opposite of a negative is still a positive slope. So let me go, instead of rising up 3, we'll go down 3. And instead of increasing to the right 4, we'll go to the left 4. And let's do it again. A fall of -3, a run of -4. And I just want to point out, now we have a whole lot of points where we feel a lot better about graphing the line through those points. Make sure you point out that that line, that set of solutions to this equation, would go on forever and ever and ever. Where is the y-intercept? Slide on up, boom, 0, 0. So we'll write in 0, 0. All right, one more. Pause, rewind if you have to. Meanwhile, let's go ahead and first plot this point, which is in the 4th quadrant because there is a +3x coordinate and a -4y coordinate. Now let's take our slope. Wait, Mr. Callan, that slope is -2, but we need a rise and a run. Okay, well, let's make it have a rise and a run. In other words, what number can we put down in the denominator as the second part of the ratio? Well, can't put in a 3, you can't put in a 13, you can't put in a -1, but you can put in a +1. Now think about that. -2 divided by 1 is still -2. But now we have a rise and a run. So I'm going to go to that point that we have on our graph in the 4th quadrant. I'm going to rise, or should I say fall, 2 down, 1 to the right, and there's our next point. 2 down, 1 to the right, and there's our next point. 2 down, 1 to the right, and there's our next point. Mr. Callan, we're out of space. Well, let us go in the opposite direction. Instead of going down, we can go up. Instead of going to the right, we can go left. After all, the opposite of a positive is still a nice negative slope. So now we're going to go 2 up, 1 to the left. There's a point. 2 up, 1 to the left. There's a point. And we can keep going and going and going, ladies and gents. 2 up, 1 to the left. Frankly, the more points, the better, because it just makes for a straighter line. Shoot, I don't even probably have to use the line function, because I got so many points that I can draw a, oh yeah, I definitely should have used the line function. All right, where's that y-intercept? Put that star and let it slide on down, boom, until it hits the y-intercept, which appears to be at the point 0, 2. So what do we learn? Anytime you have an integer slope, we can turn that into a ratio by simply putting a 1 down below. You may also reverse the symbols or signs. The opposite of a positive is a negative. The opposite of a positive is a negative. So you can go down and to the right or up and to the left and still have a nice decreasing negative slope. Let's do another one, shall we? -2, -4 will be in the third quadrant. -2 goes to the left, -4 goes down. Slope of 5, we know what to do with that. Let's just simply put a 1 under here and get ourselves a rise of 5. 1, 2, 3, 4, 5, and a run of +1. And there's our next point at the point -1, +1. Let's do it again. 1, 2, 3, 4, 5, and a run of +1. And there's our next point at the point 0, 6. Now it looks like our next one would go off the graph a bit. So let's go in the opposite direction, shall we? Therefore, instead of going up 5, let's go down 5. Instead of going to the right, let's go to the left. After all, the opposite of a negative will still be a positive. So down 1 and 2, 3, 4, 5, and instead of to the right one, we'll go to the left one. And at least that gives us another nice point. Take our straight edge out. Draw a line all the way through that graph, a line that goes on forever and ever. If you really wanted, you could find the y-intercept, which appears to be at the point 0, 6. But that's superfluous. No, I don't know if that's the proper word. We don't need it. I just want to get you ready for what's coming at us in coming days. Let's do another one, shall we? -1 to the left, +2 up. Now this is interesting. According to this, we could either go down 1 and then to the right 2, or we can go up 1 and to the left 2, and either way it's going to be okay. So let's go down 1 and right 2, down 1 and right 2, down 1 and right 2, and continue on for a good amount of time. Of course, if we go down 1 and right 2, we could have also gone up +1 and left -2 and still arrived at more points. So let's do that starting back from our original point. Let's go up 1 and left 2. There's a new point. Up 1 and left 2. There's a new point. Up 1 and left 2, up 1 and left 2, and so on and so on. Now we have a good series of points. Please notice that they do sure seem to go through it, shall we say, in a nice straight line. If you see a point that it seems a little jig-jagged off of it, then go ahead and go back, look at it, see if you can find or identify one point that just doesn't seem to work. P.S. If you wanted that guy to slide on down, oh, this is interesting. It appears to be in the middle. And if it's directly in the middle, 0 to the left or the right, it looks like 1.5. And of course, you could write that in decimal form if you'd prefer. Shoot, you could write that in a number of ways, representing that quantity several different ways. Folks, that's what I got for today. Notice we are on assignment number 9. Sorry that video took a while, but this is a really important task. I wanted to give you plenty of examples. Take care, do well, and let's grow. I'll see you all Monday.